What took you so long? The show's about to start.
Because of that door, I wonder why it is harder to open near the hinge than near the doorknob.
Good thing you came. That's what we're about to watch.
Have you ever wondered why it's easier to open a door when you push it at the edge rather than in the middle? To understand this, we need to understand what torque is. Torque is a fundamental concept in physics that describes the rotational force applied to an object. It is defined as the product of the force applied to an object and the perpendicular distance between the point of application of that force and the axis of rotation. Torque plays a crucial role in rotational motion as it causes objects to rotate or change their rotational speed. The greater the torque applied, the more rotational acceleration is produced. Additionally, torque is responsible for maintaining the equilibrium of rotating objects and determining their stability. Think of a wrench and a nut which is seized up. Using a small wrench is very hard to free a nut. Using a long wrench, it will make it much easier. That's because of torque. If we use a 30 cm wrench and applied 90 newtons of force, we have 0.3 meters multiplied by 90 newtons, which give us 27 newton meters of torque. However, if we apply the same 90 newtons of force to a wrench that is 60 centimeters long, then we would get 0.6 meters multiplied by 90 newtons, which give us 54 newton meters. So, from this simple formula, you can see we have more force acting on the nut by using longer wrench. Another demonstration is the rotating chair and weights. A volunteer sits in a rotating chair while holding weights. As they extend their arms outward, increasing the distance from the axis, the rotation slows down. When they pull their arms inward, they rotate faster. This demonstrates the concept of torque alongside the conservation of angular momentum. It highlights how changing the distance of mass from the axis affects rotational speed. Now, to answer the question why it's easier to open a door when you push it at the edge rather than in the middle is because the harder you pull on the handle, the more torque you'll generate and the more you change the door's angular velocity. More net torque then means the door starts moving faster on its hinges, so the strength of the force that's applied is one factor that affects torque. Another is the distance between the force and the axis of rotation or the radius. A larger radius means more torque. A door with a handle close to the hinges would be much harder to open because you get less torque for the same amount of force. One of the practical applications of torque is the transportation such as bicycle and car. If you ever ridden a bike, you know it's very difficult to start pedaling in a high gear. So we need to start in a low gear to get the bike moving. At a certain point, our legs are spinning very fast but we can't go any faster. So we need to change to another higher gear. Once we reach a steep hill, we need to move to a lower gear. The same with a car. We start in our lowest gear number and work our way up as the vehicle increases in speed. Then we change down as we drive up a hill. Torque makes our everyday life easier, more efficient, and more controllable in various ways. For example, using a long wrench to tighten a bolt demonstrates how torque reduces physical effort by providing greater leverage. In vehicles, the torque generated by the engine powers the wheels, enabling efficient motion and acceleration. Similarly, when a cyclist pedals a bike, torque is transmitted through the chain to the wheels, showcasing its role in maintaining control and enhancing efficiency. These examples illustrate how torque simplifies tasks and optimizes performance in daily activities.